Thank you. So here we are again talking about exfiltration again. So it fits in this discussion of serious game because we use actually these same, not same, but almost same presentation and the same training in one of our course in botnet exfiltration, botnet mitigation course that we do in with the center. And so we are actually using the same technique to train our students to be prepared of what I will be facing. So we saw lately an increasing on stealing data for commercial purpose, for government espionage, and so on. So it's a criticality at the moment, is what we are worried about. So what is exfiltration? So the exfiltration is a malicious activity, of course, because you carry out without authorization of the owner of the information that you want to steal. And you perform this from an infected machine. So you have to infect a machine and then steal this information. The sensitive information is whatever information you have that's losing this information of the access without authorization or disclosure may produce security effect on the owner of this information. So the exfiltration scenario is quite classical. So we have an infected machine that is usually located in an internal network that should be protected. And what we want to do is to extract this information from the internal network to an external server, an external place owned by the attacker. So we see that the scenario of the attack is inverted. So we are not attacking from outside to inside, but we reverse the scenario and we move the attack from inside to outside. So this is quite interesting. So as we discussed in the workshop the other day, there are plenty of different methods that we can use to exfiltrate data. And depending on the malware or the scenario that we are facing, we see different techniques being used, like FTP, emails, normal HTTP protocol, steganography as well, so the information are placed inside image or inside other kind of data, VoIP, as we described during the workshop, and also some sort of encryption. In this presentation, we'll not talk about strong encryption because it's not being used so much by the malware that we see every day, but more on obfuscation. Obfuscation is more used because they are much simpler, easy to implement, not really heavy for computational, but still work because it creates the enough difficulties for the reverser, enough to do the job. So here we see some examples, the more used, like for example XOR, that is an logical operation performed by 2 bits. And then there are different techniques that can be used using XOR, like the roulette XOR. So we roll the key every time we XOR one information. Chain XOR, so we perform the operation per each byte concatenated with the previous one. And the classic one uses the fixed key. But also there is a modified version of CSR13 that is one of the techniques that we will be using in our exfiltration as well. Of course, as I said in the workshop, the CSR13 works only for characters. So if we want to exfiltrate any kind of data, we need to extend this algorithm for obfuscation for any kind of characters. And then we will discuss about the polymorphic blending in more details. So the technique is quite obvious. So what we want to do is that we want to hide our information, the information that we want to exfiltrate as much as possible with the traffic that we have, so that we cannot raise any alert. And to do so, we use network statistics. So we try to emulate the normal behavior of the network. We use statistic of the payload, so the kind of traffic that usually travel in our network. and also other manipulation of the traffic. So the technique is divided in two main phases. So we have the first phase where we create our network profile. So we start to collect the network traffic. We start to extract the information that we need in order to have a view of what is going on in our system, in our network. Then the second phase starts. When we have all the information we need, we can start to emulate this information and start to perform our malicious activity. That's the second part, the blending, where we actually obfuscate our payload and we manipulate the traffic upload in order to simulate the normal traffic. So here we have an example of the bytes distribution. So we need to know the number of the character that travels in the network. We need to know how many of those are used and the distribution that we have. Here in red, we have a normal connection that we collect. As we can see, we have spikes and we have like general distribution, quite normal. And then we have the file that we want to exfiltrate. Of course, the file has use different bytes and have a different distribution. So if we look at the content of this connection and the file, we can see that there is difference. So if we try to exfiltrate this file, statistically, we raise an alert because we have these differences. So what we want to do is to substitute the byte distribution of the file with the byte distribution of the connection that we have. And here we have an example of the substitution that we perform. So our goal, the goal of our exfiltration is, of course, to avoid the detection. So we want to avoid that someone detects our activity. And in our case, the adversary is the intrusion detection system. So a system that is placed in the network in order to check if something wrong is going on in the network. And we are facing the signature one and the anomaly one, so the both typology of the intrusion detection system. Then we build a tool that is able to exfiltrate sensitive data using polymorphic technique and also other obfuscation method as well for the sake of the test, in order to test if these intrusion detection systems are actually good enough for detecting the exfiltration. But in order to implement the polymorphic blending technique, we need to know which kind of information these intrusion detection systems are looking for, so that we can accordingly modify our technique in order to fool them. So we select Snort as a signature-based intrusion detection system. Then as anomaly one, we picked MacPad, that is an academic solution intrusion detection system, and an extension for Snort that do anomaly detection. And then we select two hybrid solutions like Suricat and Bro. So during our study of the intrusion detection system, we are able to select this kind of feature in the network that we want to collect and extract information. So for general statistics, so the statistic for every kind of connection that we have, we want to collect the rate of connection established. So how many connections we establish in the infected machine in average. The range of our activity. So if we want to exfiltrate some data, and for example, we do it during nighttime, when usually the system are not performing any activities because no one is sitting on the desk, then it will raise an alert because some activities from a PC that shouldn't be happening. Then we study the frequency of port use so that we know which are the more common ports that are being used. But then also for each and every connection that are established in the system, we collect the inter-packet delay that is really interconnected with the bandwidth of the connection, the protocol name, so if it's TCP or UDP, the packet size, and the ID of the connection to identify a specific one. But also for the payload, we collect the payload size, the entropy, that is really important in order to extract the distribution of bytes inside the payload, inside a single connection. But then also for global statistic of the infected machine. Since we are infecting one machine with a tool that performs different activities, we need to know the average of CPU load and memory load, so that in case there is placed an intrusion detection system for the OS, it will not raise so much alert because we stay in the average of the normal usage of the infected machine. So this is the design of the exfiltration tool. As we can imagine, there is the collector, that is the first part of the technique, and then the blender. They are the two mains. And in common, there is this statistic table. So a place where we store all the information, all the statistics that we extract from the network. So the collector, of course, as I said, sniffed the local network, so the local interface of the machine, in order to create this normal traffic. And the normal traffic is stored in the statistic table. In the statistic table in particular, is stored only the closed connection, so the connections that are stable. If we have a still open connection, it will be placed in a temporary one, because the statistic will change over the time, so we don't want to have different type of data every time when we exfiltrate. So we store only the closed connection. So here we see an example of the tool, and this is the statistic table that will be stored in the tool. So we have the general statistic here, rate of connection established, inter-packet delay, ports, the time frame. Here I was performing this test in the afternoon, so you can see there is only activity between 12 and 18, so in the afternoon. Then we have this, that is the statistic table, where we have only close connection. And for each connection, we record entropy, the packet size, the bandwidth, and so on, and the protocol as well. And then we also have the temporary connection. Oh, yeah, there it is. Then on the other side, when we collect all this information, we want to exfiltrate. That's our purpose. So we calculate, first of all, we select the data that we want to exfiltrate. So we select one file, and we calculate the entropy of the specific file in order to have an idea of the byte distribution that the file has. And with this entropy, we look in the statistic table a connection that has the closest entropy, so that has pretty much the same characteristic of the file that we want to exfiltrate, so that it's easier for us to emulate the byte distribution. Then we wait for the right condition, for example, the time frame during the day, and then we start to exfiltrate. We can use 3 different kinds of obfuscation. This is implemented in the tool, mainly for testing, because of course our main concern is the polymorphic blending technique, but we also implement this other technique for test the intrusion detection systems. And this is the example of the exfiltration that we saw during the workshop. And the interesting part is here. So we select the file, we create the conversion table, because we read the file, we extract the entropy, we select the connection, and so on. Then the conversion table is the table that's used to obfuscate the file. Since on the other side, we need to deobfuscate the file, we need to send also this table in order to decrypt it on the other side, of course. And then we use the protocol of the selected connection, and we start to exfiltrate data. And on the other side, we will receive it. So the evaluation is, of course, done in a simulated environment, and our interest is on the intrusion detection system. So we want to see how the intrusion detection system react with different kind of exfiltration. So we test all the 4 intrusion detection systems that I described at the beginning. With all of them, we start that configuration, except for the signature one. So we implement signature for the signature base, and we create the network profile for the anomaly one according to my normal activity during the day. Then we use the 4 different kinds on different intrusion detection system. And the results that we are interested in is the exfiltration time, so how much time it takes to exfiltrate with different techniques. Are we actually able to exfiltrate without detection? And is there any threshold where we can play to, I don't know, use more bandwidth, less bandwidth, and which threshold do we have for a safe exfiltration? So we select different sensitive files, different kind of files with different entropies and different size. And here we have the list of exfiltration time. And what is really interesting is that, for example, for some file takes a lot to exfiltrate. For an Excel file, it takes 40 minutes to exfiltrate completely. While with the normal exfiltration, it will take seconds, less than a minute for sure. Especially if the file is really large, like an image, it takes more than a day to exfiltrate. These are not fixed time. Of course, if we select a different connection that has a higher bandwidth, will be much faster the exfiltration, but still will be this kind of time, more than a normal one. This is here an example of the exfiltration. So in blue, we can see the transposition of the bytes that we want to exfiltrate. So here an example of detection from signature one, from the signature intrusion detection system. So an example of what it means being detected. Here the detection of the anomaly based. We can see that there is no classification, but just an alert that something unusual is happening in the network. And this is the final results. So for snort and suricata, of course, we have the obvious results. So if we apply no obfuscation at all, we just exfiltrate plain text, we are able to be detected. Okay? But as soon as we use some sort of obfuscation, that the signature one is not working anymore. So we are able to fool them. Instead, with snort AD, so we use some sort of anomaly detection, then also the obfuscated one are detected because it used no blending. So the traffic is not modified. So we just send normal traffic, just obfuscated. But for our technique, the blending technique, we are able to perform a safe exfiltration. Instead, for MacPad, we had really bad results. Actually, we are being able to exfiltrate everything every time. Maybe because MacPad is particularly tailored for specific detection. So it claimed that it's able to detect polymorphic blending attacks. So apply the same technique for attack, to sending exploits to an infected machine. But for the exfiltration, no, it's not able to detect any of them. So from this snort AD, we also extract some extra information. So we are able to perform a safe exfiltration even if we modify the bandwidth of the exfiltration up to 30% more of the average allowed in the connection. This is due to of course, the safe threshold that the intrusion detection system have to avoid false positive. And we are able to play with this adding up to 30% to still have a safe exfiltration. So in conclusion, so the signature one can be easily fooled with just classic and normal and really basic obfuscation. But as soon as we apply more advanced anomaly detection, then the game becomes a bit harder, because the anomaly one is able to detect some anomalies in the network, and so it's still able to detect something. But with our technique, the polymorphic blending technique, we are able to fool also the anomaly one. And the tool is able to exfiltrate safely sensitive file. Thank you.
Thank you, Matteo. Are there any questions from the auditory? Yes, please. There is a question. The mic is coming.
So hi, I'm Philippe Rochebon from Cisco. I found this very interesting, but it seems to me that the people who will benefit the most from your research are the hackers. So it's, once you publish it anyway, so is the next phase of your research to actually find ways of detecting people using polymorphic blending, or are you planning to move to the dark side?
The dark side is a really interesting side, but anyway, no. I will not tell you anyway, so if I do. But the idea behind this research is that we noticed that the intrusion detection system is definitely not a valid solution that we want to place in a network if we want to stop an exfiltration, because it's not up to the task. And for what concern our technique, we thought about some solutions, some improvement that can be done in the intrusion detection system in order to detect. But is all of the modification that you place in intrusion detection system are just little bit tailored for the specific technique. It's not a final solution. So the idea is that our research say that the intrusion detection system is not a good solution for stopping an exfiltration. That's our idea, yes. There are different points of view that can say that this technique can be detected. For example, if you have a single connection for 30 hours, you know, that's something that you notice if you have a proper configured intrusion detection system. Or for example, you have the first packet every time is the exfiltration, the conversion table that has a fixed site. So you can create kind of a signature for that specific site. Not for the payload, because we always change, but for a specific file. But this is really tailored for this particular exfiltration that can be fooled easily again. For example, we stop the connection every 2 minutes, and then we start a new one, keeping the exfiltration. So, yeah.
Right.
So the idea behind is that the intrusion detection system is not up to the task for stopping an exfiltration.
Are there any additional questions? Yes,
yeah.
please.
I am Mirko Marchetti from University of Modena in Italy, and I would like to ask you, well, there are several vendors that are now proposing data loss prevention systems or data leak prevention systems. They come after the acronym DLP. I would like to ask, how do these kind of products relate to your work and to the scenario that you described, and if you could please elaborate a bit on that. Thank you.
So the data leakage prevention system that we see as commercial solution today, they are more focused on particular protocol, like they are mainly focused only for HTTP connection and SMTP connection. So as long as you use another protocol, like normal TCP, or I don't know, any Skype, for example, then they cannot do anything. So yeah, this is good because normal exfiltration are happening using those protocols. But as long as you change, the exfiltration is really tricky, I would say. Yeah.
Yes, please. The question.
Actually, I will not ask a question. I will make a comment. We already argued with the presenter the other day. If you want to stop the exfiltration, if you put your servers in a DMZ zone, and if you restrict your clients storing files on their devices, and if you prevent network traffic initiation from your DMZ zone to the outside of the internet, if you prevent this from happening, so then you can stop the exfiltration from your servers.
It can be, but it can also not be. But the idea of this stopping the others, so the create of the connection from inside to outside can be valid on a specific scenario, so in a specific network, like I don't know, classified network or internal network, whatever. But if you have a complex network, like a big company like Cisco that they employ, manage sensitive files, sensitive information, but they also want to be connected on internet to doing their job, is not something that you can apply.
The gentleman in the first row is very active. Do you have any question? No. Matteo, I have a, yeah, please.
Just a quick comment on that. We were just talking about whether IDS are capable of detecting such an attack or not. So whether you, for instance, figure out if you have a computer and like a host which is infected, and which is searching for data on a server. And whenever you place an EDS or an IDS in between the host and the server, then you will obviously be able to detect something. Because your host needs to look on your server, which is in your company, for relevant information. In this case, you cannot use some sort of polymorphic blending because it won't help you anything. Whenever you, as a company, take the fact for granted that you may have an intruder which is coming from the inside,
Right.
and you get rid of the traditional idea of having an IDS just at the backbone of your network, then you're able, obviously, to detect something. I'm not saying you're able to detect everything, but an IDS is not only to be placed on the border of your network, but also to inspect traffic at the heart of your network.
If I may add, from my own experience from the cybersecurity challenges, the IDS that we have applied, it has this home network and external network definition, right? And this is one direction. And typically, what we have seen, we failed at detecting it in the other direction because the rules are not being applied as well. Matteo, do you have any comments on?
Yes, of course.
Right.
You have to, when you place an intrusion detection system, you are placing in a specific part because you want to check and control that specific connection, the traffic that are going on in that specific part of the network or in another part. But these scenarios that we tested, of course, and we want to exfiltrate outside. That's why we place the intrusion detection system, of course, at the border. Yeah. No, but I agree with you.
Right. Thank you, Matteo.
you.
It was great pleasure having you as
Thank you
well.
very much.
Again.
Yeah, I got the mic.